There are many benefits to modeling with dynamic arrays. Most of financial modeling with dynamic arrays is simple and straightforward, such as setting timelines and flags. Some financial modeling calculations, such as the common corkscrew account, require a little assistance from LAMBDA or 5G functions. But there are financial modeling sections that, when using dynamic arrays, require more than a little assistance. One such section is calculating dividends. Here's a traditional schedule for dividends. It all works fine with static cell references. But when we use dynamic arrays, we get circularity errors. This is because Excel treats an array as one thing and not individual cells. Thus, adding a transaction array to an opening balance array to calculate a closing balance array, and then using the closing balance array as the opening balance array, even though the value is coming from a different column, to Excel, that looks like circular equation. The way around the circularity is to process the dynamic array one column at a time, just like static cell references, and we do that with a method known as reduce and stack. If you are not familiar with reduce and stack, you may want to review it first using the link in the card above or in this video's description. Reduce and stack will be used as part of an overall process to reduce schedules, like this dividend schedule, to bare essential calculations and convert them into a dynamic array-friendly function. The function's results can then be formatted to display the dividend schedule as the modeler sees fit. The process is straightforward. It starts by simplifying this section by removing everything that isn't essential. To identify what is essential, we hide all columns that simply repeat column J and then reveal the model's formulas using formula text in the first open column. Each #NA points to hard-coded values, which are placeholders for calculations that this section uses as inputs. We move the inputs out of the calculations for now. Some of the inputs are duplicates. We decide which input is the original, point all formulas that reference the duplicate to the original, then delete the duplicates. Some of the formulas merely point to other formulas. We call these links. Find all formulas with references to links, point them to the origin cell, then clear the links. Remove all blank lines so we can visualize these formulas easier. Place values left of model start, such as opening balances, above, and place formulas that reference other formulas below. The section's inputs are first. They include cash flow available for dividends, dividend distribution flags, and profit after tax. Inputs also include balances prior our model's timeline, which include retained earnings and retained cash. LAMBDA functions do not have cell references, so we must convert the cell addresses in each formula to reference names. To simplify this task, we are using a free 5G function called refs to texts. A link to this function is included in the card above and this video's description. These labels are highly descriptive but too long to be practical in formulas. We can shorten them with mnemonics. Mnemonics are a series of letters or numbers that help us remember something. In this case, we use RC for retained cash, RE for retained earnings, CF for cash flow, and so forth. Using mnemonics as formula references makes formulas self-documenting and easier to understand. These formulas are all that is needed to calculate dividends using this method, and we will use them exactly as we see here to create a function we can reuse anytime our model needs to perform this calculation. We are calling our function dividend calcs. Its required inputs are cash flow for dividends, profit after tax, and dividend distribution flags. Its optional inputs are retained earnings opening and retained cash opening. Because this function will have multiple formulas, we must add a let function. The first formula tests if retained earnings opening balance was omitted. If so, we default it to 0. The second formula tests if retained cash opening balance was omitted, and if so, we default it to 0 too. To mimic financial modeling's calculations by period, we will use the reduce function with a period counter. One way to create the period counter is to use columns to determine how many period columns our model has and provide that to sequence to create a counter from 1 to the number of periods. Reduce has two arguments, initial value and array. We do not need the initial value, so we will set it to 0. The array is our period counter. Reduce will pass each element of the array to its lambda, one at a time. Reduce's lambda starts by receiving reduce's initial value in a variable we call ACC, which stands for accumulator. The accumulator starts with reduce's initial value, but after that, the accumulator contains the last result of reduce's lambda. We use period to select values from arrays. Our first array is the cash flow for dividends argument. We place the period's value for this array in CFA4div, which is a mnemonic for cash flow available for dividends. Likewise, we use period to get the period's profit after tax and dividend distribution flag. If period equals 1, we are in the first period, in which case our retained earnings opening balance must come from our retaining earnings opening argument. If we are not in the first period, we will get our retained earnings opening balance from the accumulator's last column, which is the prior period's column. We do the same thing for retained cash opening balance. We can now calculate this period's cash available for dividends, which is the maximum of 0, or our retained cash beginning balance plus cash flow available for dividends. We multiply this by our dividend distribution flag, which governs when dividends are dispersed. Similarly, our earnings available for dividends is the maximum of 0, or our retained earnings beginning balance plus profit after tax. Dividends due and paid is the minimum of cash available for dividends and earnings available for dividends. Retained cash ending balance is the beginning balance plus cash available for dividends, less dividends due and paid. Retained earnings ending balance is the beginning balance plus profit after tax less dividends due and paid. With all of this period's calculations completed, we stack our inputs and calculation results into the periods column. If this is the first period, we put the column into our accumulator. Otherwise, we stack this column against the prior period columns held by the accumulator and hand that back to the accumulator. We continue this process for all periods, and when finished, we return a block of calculations. Our function is ready for use. This one function in one cell produces all the essential results for our dividend schedule. If we want these results in the original format, we can create a function that calls dividend calcs and stacks its results among blank rows, duplicated inputs, and links. Converting common schedules to dynamic array functions is a straightforward process that provides us an easy-to-use and easy-to-import solution, saving us time and preventing errors with each reuse.